All right. Hi, everyone. Thank you so much for coming to PyData Global. We're so excited to have you join us. Feel free to use the chat feature in this session to connect with your fellow attendees, share your thoughts during the session. Also, if you have any questions, you can post them in the Q&A tab, which will be on the right-hand side, and we'll address them at the end of the session. Now, it's my absolute pleasure to introduce Daphné Grasselly, who'll be presenting Enabling Multi-Language Programming and Data Engineering Workflows with the Snakemake framework. So please, let's give a warm virtual welcome to Daphné.
Thanks a lot. Thanks a lot for joining and welcome to this presentation, Enabling Multi-Language Programming in Data Engineering Workflows using the Snakemake framework. Before starting, maybe some quick words about me. So I'm Daphné Grasselly. I'm currently Senior Data Scientist at Roche. I moved recently actually to Switzerland to work at Roche in pharma industry. Before I was based in Toulouse, working mostly in aircraft industry. So I switched a bit working from geospatial data into pharma data and metadata. And during my career, I started more as a data scientist. And more, I got more and more interest into data engineering role and software development. So I learned also more about big data processing, doing PySpark. I mean, Python is still my main programming language anyway. I worked also in doing some cloud computing, and also I'm really interested about DevOps. So I worked also a bit with Docker and enabling some CI/CD pipelines internally. Still at Roche, actually doing some CI/CD pipeline with GitLab, but also working with GitHub Actions for open source packages. So let me start now with the table of contents. Before going deeper into the technical topic about Snakemake, I wanted maybe to bring some context about statistical environment for clinical trials. Then I will also introduce our main problematic here. Then I will introduce the Snakemake framework, and then how do we use Snakemake to solve our main problem, and then introduce next steps and areas improvements. So, sorry, I have some issues with this like this. Okay, let me start first with some context about clinical trials report submission. So maybe more starting with my own team, actually, we are called Data Science Acceleration. So our end users are statistical programmers. They are internal users at Roche, and we are responsible of providing several automation tools and data libraries and moreover like a data platform to execute different programs. So our end users are statistical programmers and data scientists. And now I can introduce a bit how our end users, the statistical programmers, are working daily in the clinical trials data. So of course, they first start with patients' data. And then they will need to do several steps from this raw data, following some health authority standards. So the first step is to compute what we call SDTM dataset. It stands for Study Data Tabulation Model. So it's about processing this patient's data. We could see it as doing some data cleaning to be compliant with some standard data sets. Then from this SDTM, they need to compute the ADAMS dataset. ADAMS stands for Analysis Data Model. So this is more about computing what they call derivations, so doing some aggregation in SDTM data, adding some new columns. And then from this ADAM datasets, they need to compute what we call TFL. It stands for tables, figures, and listings. So mostly graphs, tables. And then at the end, these TFLs are really important because they will use it to insert it in the final report, what we call CSR for clinical study reports. And actually, this is the report they need to submit at the end to health authorities. So like the FDA or European Medicines Agency. And they are working specifically in the step where they submit to health authorities, and it will determine if the medication go to market or not. so quite an important step. And to be able to compute all these data sets from SDTM to TFL, they are using several programming languages, using R and mostly SAS programming. Historically, in a lot of pharma companies, SAS was really the first language because this is kind of validated language to do statistics and to be sure to have accurate results. More and more, there is a transition in pharma companies to go more and more into R and to open source languages. And we have really this objective going 100% to R programming. But in reality, this is really hard to make like super hard transition to R programming. Because actually, when we are talking about studies, sometimes from one study to another, they can reuse some programs. So they are going a bit quicker reusing some SAS programs. So it's a bit hard to ask everyone to do super hard transition and do directly R programming. So you can see in our case, we need to support multiple language to do this data engineering tasks. So what we are working on with my team is actually enabling a multi-language programming platform, a container-based platform. If you don't know anything about Docker images and containers, no worries about this. I will try to introduce this, giving maybe a high-level view during this presentation, because we will come back actually to Docker and containers. But anyway, for end users, this container-based platform, it enables users to run SAS or R programs and also edit the programs, execute them. So in reality, from end users, they will start SAS and R containers. This means that they will have the possibility to access online IDE to do the code and execute it. So they can access SAS Studio online IDE or R Studio. So if I come back on the initial context from SDTM until the TFL computation, we have a set of metadata associated to it, historically in a spreadsheet, where the users are specifying all the clinical plan. So really the list of all outputs they need to produce with a lot of metadata. And inside this metadata, we have also the specification of the program producing this output. For sure, we wanted to transition into a more modern technical stack. So these spreadsheets, we are replacing it with a React web application, where all this metadata now will be stored in a document DB. Of course, the backend is in Python. And actually, from this metadata, we thought it could be useful for end user to have the possibility to run the different programs. But in reality, this is really complex because when you talk about SDTM, ADAMS, TFLs, we are talking about hundreds of programs. And also we have a notion of a lot of dependencies between programs, so interdependencies between SDTM, ADAM level, but also internal dependencies between ADAMS dataset and SDTM datasets. So you can guess running this manually, it's quite difficult. That's why we wanted to use an orchestration framework, a workflow management system. And for this, we are using in our solution the Snakemake framework. So let me now introduce what is exactly the Snakemake framework. So Snakemake is a workflow management system. This is a Python library based on Python and Make. If you know a bit about Makefile, this is the same principle where you have several tasks and dependencies between them. And then when you are using the Snakemake framework, you need first to configure your workflow. So for this, you need to specify a snake file, defining several rules inside this snake file. So you can see the principle of a rule is quite simple. This is about defining inputs, output, and shell, and giving a name to your rule. So mostly, you need to define the shell, the inputs for your program, and the output produced by your program. So this looks a bit like YAML file. In reality, you can go a bit further because in reality, this is a bit a mix between this rule YAML syntax, but you can also choose to insert some dynamic Python code. So for example, in this case, we are reading some input data and we can reuse this variable directly inside the rule. So once your snake file is ready, you need to run a specific snakemake command inside the terminal. So it will be snakemake, and you give the name of the rule you want to run. In reality, there are some other parameters, but we will come back to this. And at the runtime execution, the Snakemake framework will actually read all the rules and figure out the dependencies graph, the directed acyclic graph. So it will figure out which rule needs to run in which order. And one important thing is that it's also allow parallel runs. So if you have 2 or 3 rules that can run independently in parallel, it will also figure out that it's possible to run them in parallel. So maybe let me give some more concrete example. I did really one simple one with 4 rules here. So we have create A that doesn't have any input dependencies and just creates A txt output. Create B and C that needs A input and are creating B and C.txt output. And then the create D rule reading the create B and create C outputs and producing the D.txt output. So when we are running Snakemake, there is also a possibility to visualize this workflow. This looks like this actually. I did a screenshot actually running this the D rule, so you can see the different upstream dependencies. And something I wanted to explain also, when you are running Snakemake commands, it will read all the timestamps of the produced datasets. So for example, if I want to run create D rule, and I didn't make any change in B, C, or A, Snakemake will be quite smart and figure out I will do nothing because actually nothing changed. But if there are some timestamp detection change, for example, for create A outputs, then if you want to run create D, it will automatically rerun all the upstream dependencies. So by default, it's using the timestamps. It's also possible to do more custom work using, for example, custom checksums, where instead of using the timestamps, it will check more the content of the datasets. Now I wanted to introduce another concept, which is the singularity mode. So this mode enables to run the different rules in Docker containers. I was talking about Docker containers previously, that I will give a high-level view of it. So for this, I will try to do also an analogy with Python programming, actually. So when we are talking about Docker, we usually talk about Docker images. Docker images, they are built from a Docker file. You can see this in Python when you create your package code and then you build your package. The difference is that in Docker file, you will set up more like an environment. For example, you say, I want to use Python, I want to install a list of requirements, pandas, for example, or I want to use R and install R libraries. So this is what you specify in your Docker file. Then the Docker image, you can push it inside a container registry, or also pull some images from there. So as Python developer, you can see this like Python package registry. And then from this Docker image, you can run a container instance from it. So it would be like running a program in Python. So this will be like a segregated environment containing all the installation specification you put inside the Docker image. To make it really more simple, even if it's not completely true, you could even see it like a lightweight virtual machine where you have really your segregated environment inside it. So if I come back on the Snakemake rules definition, there is also a possibility to specify container fields. So inside you will specify a Docker image path. So it will behind pull this image and run your rule inside a specific container, so in a segregated environment. In reality, this is a bit more complex because Snakemake is not really using Docker images directly. To be able to use this mode, you need to use singularity images. You can see this like Docker images, but with a different format. I won't go too much in details anyway on this, but just to explain maybe why it's called singularity mode. So if I go back on our initial example, with this simple example of 4 rules, you would have the possibility actually to run your different rules in different containers. For example, I want to specify A need to run in Julia, create B needs to use more R environment, and C and D specific Python images. So you can see with this mode, it's really easy to enable running rules in really segregated environments. So I think this is really powerful feature of Snakemake. And what I wanted to introduce also, it's a different commands when you want to run your Snakemake framework, when you use a Snakemake inside your terminal. There are really plenty of options. So of course, I cannot introduce everything here, but if you look at the documentation, this is really clear and well explained. In my case, I wanted to show some example. For example, the force all option. I was talking previously about the timestamps detection when you are running your workflow. This force all, it's enable really to run all the upstream dependencies, even if Snakemake didn't detect any changes. And also, I was talking about parallel runs. You can specify the number of cores you would like to use. By default, I think it's using all the cores available in your local infrastructure. Now, I wanted to go maybe a bit more deeper. This would be maybe for more advanced usage, I would say, of Snakemake, once you are a bit used to it. It's maybe to design proper snake files, I would like to say. So one notion I wanted to introduce is the wildcards. I will give an example for this. So we have, for example, this snake file with the rule all. You can see rule all is referring multiple parquet file. And you can see that we have upstream rules, CSV to parquet, responsible of converting these CSV files into parquet files. And when you look at these upstream rules, you can see there are really definitely a common pattern if you look at the input path structure and the outputs. So you can see here kind of redundancy. And it would be really great if we could refactor a bit this snake file, especially imagine if you have like 50 rules CSV to parquet. To be able to do this, there is a feature in Snakemake called the wildcards. So it looks a bit like this notation. Instead of specifying all the CSV to parquet rules, you can refactor this into a single rule. So what will happen here actually when you run the rule all, it will detect this common pattern. For example, that if I look at the first input, it's located in results parquet and it concerns parquet files. So Snakemake will figure out this wildcard notation and look at the CSV to parquet rule. And automatically it will consider the sample between braces as a placeholder. So when running the all rule, it will replace this sample notation with data 1, data 2, and data 3. This may be a bit harder to understand. So yeah, if you want to go a bit more deeper in snake files, I invite you to look more in details the documentation. And we have also some helper functions. I think many helper functions. Actually, here I wanted just to show maybe one simple example where instead of defining a list of inputs, also you can use as well a specific notation. It looks a bit like the wildcard one actually, but you can use the expand function to create your list of inputs following also a specific pattern. And here we are replacing the sample variable with actual data. It will create the list of inputs under results parquet folder for us directly. So now I explain a bit the concept of Snakemake. I wanted to introduce a bit more in details how we are using it in our current statistical computing environment. So to come back in our metadata, I was talking about this metadata definition where we have all our data sets with the programs defined somewhere. So for this, actually, we have this React web application and all the metadata are stored in a document DB. And we have also some data stored there about standard dependencies data. So saying this dataset depends on these other datasets. So we have a concept of standard dependencies there, because from a study to another, we have usually some standard datasets to produce and as well standard common dependencies. But we have also a notion of user-defined dependencies. If user need to put some specific dependencies for some specific things in a study. So what we are doing, we are reading all this metadata, and we are using a specific framework called Jinja. So I will explain a bit more in detail what is Jinja. Jinja, it's a web template application engine. So the concept of Jinja, you will feed it with one template file and a source of data or metadata. In our case, we are building a Snakefile template file, and we are giving also to Jinja our metadata stored in our document database, and we are rendering some output snake files from it. So if I go a bit more in detail into Jinja, this is maybe a bit out of scope because this is not about Snakemake, but I still think this framework is really interesting to know because it can be useful in many cases. I think knowing this template engine could be really helpful in some of your projects. But to come back on Jinja, actually this is a bit how looks the syntax. So I give an example of a Snakemake template file. We have this notation under braces, and also this, if you see this percentage character and braces. So you can see we are looping over a sampled variable and creating some rules from it. So this is our Jinja template syntax. And then calling the Jinja framework, we will feed this template with actual data. So in this example, I'm giving a list of 3 elements. And Jinja will automatically render the associated snake file in this case with the 3 rules associated with each element of the list. So this is how we are doing things in our solution. We read the metadata and we are rendering some rules like this. So if I come back on our initial computing platform I was talking about, users can run SAS and R programs inside SAS and R containers. These containers are associated to some Docker images. So we are talking about R and SAS images here. They are stored in our local container registry. In reality, this is a bit more complex. This is not just about R and SAS images. We have also some custom installation inside these images. So for example, some Python automation tools, a lot of things, and also some libraries for our users coming from Pharmaverse. Just note about this because Roche and some other pharma companies, we are working a lot together actually in some R open source packages. And these packages, we install them inside our images. So to be able to use it to run the different programs. So at the end, our users, they will have locally the programs. They will generate this snake file from our tool. And all of these are stored in a GitLab repository. And at the end, the final orchestration, especially when we have R and SAS programs, it will actually run in the CI pipeline. So behind this, it will pull the different images from the container registry to be able to run the different rules inside a CI/CD pipeline. So this really enables this multi-language configuration problem. And I guess we could be quite flexible if we want to use Python, for example, we could add this kind of environment as well in the future. So now I just wanted to talk maybe about next steps, talking about the goods and the bads of our current solution. Maybe talking about so what is good. I think it's easy to set up when you are using Snakemake. I think it's really lightweight way of doing orchestration. Just have to install your libraries and define your rules. We can see it's easily enable multi-programming languages if you want to use containers. And globally, I think it's quite easy to understand and to start with to do an initial orchestration because you saw the rule definition is not really something really much complex to understand. And about maybe the thing we could improve, I think for me, it's really the lack of visualization in our solution. At the end, our users are using a CI pipeline, so they see this kind of logs. Actually, this is what look like a Snakemake log. It would be better, to my opinion, if they could see like a DAG diagram with all the workflow. There was an initiative from the Snakemake teams. It's called Snakeface. I've seen some images from it where they put the different rules with also associated directed acrylif graph. Unfortunately, I saw this project is not really maintained anymore. I think it has been maybe 2 years it started. Mostly because I guess the Snakemake team is already really busy maintaining the actual Snakemake framework, which is already amazing thing to have. And maybe another drawback in our solution would be that for me it's not completely automated tool, because we are still asking our users actually to specify manual dependencies in the web UI. So finally, I wanted to introduce maybe some exploration steps for next year. So one would be maybe being still open, looking at some other framework. I know Airflow is something really used also in the market. And what I like with Airflow is that actually they have a self-contained dashboard where you can see all your jobs, and we would be interested still to spend maybe some ratio in our workload to explore this kind of solution. And the other thing would be maybe about dependencies auto-retrieval. There are some ways doing this. I think the first one I'm suggesting here, parsing program files, is not the best because it would be really prone to errors from one user to another, and so from one study to another, people are not writing input and output programs really in the same way, I think. So another way could be more using watching users' local execution. Because actually when users are making a new program, they always do some local testing, running one individual run of this program. It could be maybe doing some disk monitoring. We could watch this process and looking at if this process is reading some input files and writing some output files. This is in theory, we didn't try anything yet, so I don't know if it's really fully possible, but I think it will be something I will try to explore a bit next year. Okay, I think I'm done. I think I still have 3 minutes maybe for question, if you have any questions. I see some questions on the chat. Snakemake dataset, the same as files. Yeah, maybe it's me. I was a bit unclear on this, but yeah, I would say dataset is really a local file when I was talking about it. And then I see someone is talking about Databricks. Ah, yeah, it's an interesting one. I think I used a bit Databricks, but a long time ago. So I would be interested to see this visualization possibility actually. Intake. Okay, I will take some notes maybe actually of all of this. And it is possible to see an example of the metadata defined by user. I think this I'm not sure I can show it directly, but it will look like it's looking like a table actually, with the table of your data sets and the inputs you want to associate to it. Okay, so I will have a look in Databricks. I see in the chat a lot of people are mentioning Databricks, so it seems really good to have some visualization. Thanks a lot. Thanks for the reaction. And I don't know if you have any other question, Peyton, or...
Yeah, I think we're almost out of time here. So if anyone has any additional questions, you can hop on the Discord. The link is available in the reception area, but also a recording of the session will be available shortly if you'd like to rewatch. But thank you so much for your time, Daphne, and thank you everyone for attending. We hope to see you all at some more sessions.
Thank you. Thank you so much. Bye.
Bye.